Oh, yes. Yeah.
Good afternoon, everyone. We're going to cover section 6.1 today. When we're finished with 6.1, we'll just introduce 6.2. That's what we'll do. Next class, we'll do 6.2. Next class is Tuesday, and the test will be on Thursday. Okay? So we'll go from chapter 5, chapter 6. Chapter 6 only has 2 sections. Well, we'll do 6.1, we'll introduce 6.2. This is on discrete random variables, and on the board I presented what's called a discrete probability distribution. Just one example, and I'll talk about what these are. Remember that word discrete? Countable? We'll see these values right here, 0, 1, 2, 3. Someone is attempting 3 free throws at the basket. 3 free throw shots at the basket, 3 attempts. And they can make 0 shots, or they can make 1 shot, they can make 2 of the baskets, or they can make all 3, right? And these are the probabilities of each occurring. So there's a 51% chance that individual is going to make 3 baskets, right? There's a very, very small chance, 1%, that they miss all 3 shots and make 0 of these. So I don't understand this example I have on the board, but it's called a discrete probability distribution because these values here are discrete. You know, they can't make 1.3 shots, right? They can't make 1.2 shots. They either make 0, 1, 2, or 3. All right. And what we're going to do with this discrete probability distribution, we're going to compute the expected value. If they're going to get 3 attempts at the basket, how many baskets do we expect the individual to make? So we're going to compute the expected value. All right. So let's compute the expected value. And by this concept, expected value, how many baskets we expect them to make. If they got a 51% chance they'll make 3, but 38% chance they'll make 2. We'll compute what's expected. How many do we expect them to make? A lot of you can already sense, though, it's around the 2 or 3. Do you agree? It's something because there's a really high percentage here. Someone's pretty good at making free throws. It's somewhere around a 2 or 3. We'll get a number, though. We'll be able to come up with an actual value for this. So this is called the mean of the probability distribution. That's what it's called. So I'm going to write that over here. We're going to actually find what's called the expected value. They like to write it with a capital E. All right, so expected value. But it's actually the mean. It's going to be how many baskets they make on average. They make 2 or 3 on average when getting 3 attempts. So I'm going to put this symbol down too. Remember mu? So I'm going to say mu, the mean of this probability distribution. And all we're going to do is, I know you know that symbol, summation, right? All right, we're going to sum the products, x times p of x. When this is called that big E, you can write in notes expected value. It also means the mean of this discrete probability distribution. But the formula is we're just going to sum the products here. You know, it's like, well, there's a 51% chance they make 3 of them. All right, 51% times 3. Plus 38% times 2. plus 10% times 1 plus 1% times 0. So we'll do all the products, then we'll add them all up. So if you want to come up with this expected value here, you want to just add another column. And we'll write x times p of x. We'll just multiply these right here, and then just add them up. So that's what we'll do to come up with this expected value. So here, you and I will calculate, okay, here we go. What's x times p of x? All right, everyone, what's 0? Here, just put a multiplication sign there. What's 0 times 0.01?
0.
And feel free to use your calculator. What's 1 times 0.1?
0.1.
1 times 0.1 comes out to be 0.1. What's 2 times 0.38?
0.76.
76. And eventually, everyone, we're just going to add these up. One more. What's 3 times 0.51?
1.53.
Oh, 1.53. So here's all the x. So we calculate all the products. But now we're going to sum these. And we'll come up with the expected value. A lot of us were guessing this person probably makes, we're expecting them to make about 2 or 3, right? Well, we'll get a number out of this. So let's see what we get. What's 0 plus 0.1 plus 0.76 plus 0.53? What's the sum?
2.39.
2.39?
Mm-hmm.
All right, there it is. So there's our expected value. The expected value is 2.39. And I know we're saying, well, you can't make 2.39 baskets, right? But that's our value. That's what we call the mean of that probability distribution.
So,
And it's neat in real life where this comes about. So our next problem, we'll do something, I know this is just shooting baskets. We'll do something like with life insurance and with probabilities of, people living and dying, things like that.
so if he has like 3 chances, he can make up to 2.39. There's the chances to.
That's exactly it. We're saying we expect this person, on average, every time they play this game, to make roughly 2.39 baskets. Even though you're like, well, they can't make 2.39 baskets, 2 or 3. But this example will help us understand when we do more and more problems, we're like, okay, to get this expected value, we'll just multiply the products and we'll sum them all. And we'll do some really neat problems. The next one I'll do is going to deal with life insurance. But that's what we're saying here when we interpret this, right, everyone? Sometimes this person's going to make 3 baskets, sometimes 2, but on average, he's going to make 2.39 baskets.
So what is on the y side, the 0.10?
Oh, right there?
Yeah.
That one? So
Like-
that right there, that 0.10, which is 0.1, which is what, 10%? We're saying when we interpret this out of this table, this person's getting 3 attempts at the basket, right? They're going to take 3 shots, 2, 3. There's a 10% chance that that person's only going to make one of them. He's a pretty good shooter, right? But sometimes, the first one will hit the rim, go off. The second one goes around the rim, falls out. He only makes one of them.
So then the second part is there's a 38% chance he'll make 2.
I love it.
Okay, then 51% chance he'll make all 3 shots.
Yeah. Now there's a very good. There's a very small percent chance he's gonna do what? He's gonna miss all 3. Make 0 baskets. He's a pretty good shooter, but there's a small chance it could happen. Whoop, missed. Whoop, missed. Whoop, missed. 1% chance.
Okay.
Someone got this? Oh, very good. And so this next problem we'll do is it's dealing with life insurance. The problem I'm going to pull out of the book, it's on page 328. And it's just going to be another probability distribution. These are discrete variables. Right there, that's the discrete variable. These are discrete values. You'll notice they're going to be discrete again. It's going to be money, though. It's going to be like, $300, something like that. So x, p of x. If anyone wants to know where I'm getting this from, I'm taking it from the textbook. It's on page 328. It's not a specific math problem. It's just an example one. So that's where I'm getting from the textbook. It is in section 6.1. And this is $350. All right. This value has a negative 249,650. The probability 0.998937. Let me make sure I got that number correct. 0.998937. Oh, good. Hey, just like the last problem, this column right here on the right. These two numbers, you know this, have to add up to what number? 1.0, right? Good. Just like the last one, you can add those numbers we had. They all add up to 100%. So if you're working a math problem out of the book tonight or this weekend, and they don't give you this value, they only give you that probability, then you know how to calculate it, right? All right, well in the book, this problem they gave it to you. I just want to point that out. If they didn't give this to you, just take out your calculator and go, what's 1 minus that number, and you can find this. So the number is 0.001. Sometimes they do that. 0.001063. All right. And I'll describe exactly what this is. And when this is we got another discrete probability distribution here, right? This is a life insurance policy. For an 18-year-old male. All right. And if you're wondering what amount, they always give a value to these life insurance policies. This is a $250,000 life insurance policy for an 18-year-old male. And these probabilities and these numbers, see the positive and negative? This is written in terms of that life insurance company. So if you want to call this Allstate Insurance, all right, this is Allstate Insurance right here. Here, Allstate Insurance. Now, this 18-year-old male, why is he buying life insurance? Who knows, maybe he has a child, right? Maybe this male has 2 children, but he's purchasing life insurance. In case something happens, there's money available, okay, to take care of others, you know, if he passes away. But he's purchased this. Now, what's it going to cost him per year? This policy will cost that individual, that male, $350. All right? So, do you all agree this person has a good chance of living to be 19? Mm-hmm. A randomly chosen 18-year-old male? Oh, there's a really good chance, right? He's not going to die. And there's a really good chance that this company is going to collect that $350, right? And they won't have to pay anything. True? Mm-hmm. Yeah, there's a concept of life insurance. But there's a small percent chance, right? Very small, that unfortunately the 18-year-old male may die. And how much are you going to have to pay out? Well, it's a $250,000 life insurance policy, but do you know why it's negative? Because they got to pay this, right? This company has to pay. That's why it's negative. But do you know why it's not $250 right here? Does anybody know that? Why that doesn't say negative $250,000?
Minus 350.
There you go. They already collected what?
350.
They already got that. So now they got the $350 from this individual. All right, now he passed away. They collected this on January 1st. He died on March 3rd. It's like, well, we already got the $350, and it's in our bank. So when we write the check for $250,000, right, to whoever he listed, maybe he listed his sister or a sibling, it's going to be, this money's going to be paid for his child, etc. But they write that check for $250,000, they're really only losing this amount, right? Because they already collected that. Does that make sense? That's why I wanted you to see, why is that number not $250,000 there? Because they already got that from him. So, hey, let's go over this again. There's a 99.8% chance this company is going to get the $350, right? Mm-hmm. Really good chance.
but there's a very small chance they're going to have to pay a lot of money out. All right. This goes for each 18-year-old male. Well, guess what we're going to compute? The expected value of this life insurance company. What's expected? How much do we expect this company to make or profit off each 18-year-old individual? That's what we're getting. So if we're going to compute the expected value of this policy here for this one 18-year-old male, and when we're going to find it, but boy, before we compute this, this answer better come out to be positive. Because if it comes out negative, don't you agree this company will go
Bankrupt.
yeah, they'll go bankrupt. Do you agree? So there was a mathematician behind this, making sure, looking at these odds, to make sure this amount was